Good morning, everyone. My name is Brutscher, and I'm with Samtec, where we are a global manufacturer of a wide variety of interconnects. So it's been made mention in several times in different presentations yesterday and probably today that the demand for high-functioning commercial off-the-shelf interconnects continues to increase. And as that demand continues to push us, we feel testing needs to evolve with that. So today I'm going to be talking about testing in the interconnect industry as a whole, but also where Samtec's new initiative of severe environment testing plays in that field as well. I think it's important to start with the landscape of what testing is actually out there in the interconnect industry itself. So the best way to explain that is to break this up into two halves here, opposite ends of the spectrum. So in one half you have your industry standard testing, and that's something that all manufacturers have. It looks like might be testing current carrying capacity. It sends your interconnect through some type of shock and vibe. We're checking for dielectric withstanding voltage. And although all manufacturers have that, and it may look a little different, it creates a baseline of a level of confidence for a wide array of applications. So that's great for a lot of different applications, but as ruggedization continues to increase and be wanted, it leaves a lot to want from a design engineer standpoint. So using that design engineer for the same example, let's say that they need a little bit more confidence or a little bit more testing for their specific application. We feel if there's a major jump into that next category of testing, which is the military standard certification. And although it sets the bar very high for performance and reliability, it also has its own trade-offs. It can be expensive. They can have long lead times, and as important as anything, it can paint that design engineer into a corner to have to use a solution that maybe they didn't really want, but they needed that testing for their specific application. So that's where Samtec's new initiative of severe environment testing and that middle ground testing really comes into play. Is a little bit more than that industry standard testing, but it doesn't have to meet that military standard certification. So, and as we're talking about here and made mention at the introduction, this is all driven by high-functioning commercial off-the-shelf interconnects. And we think that testing has to and will continue to evolve with that. So understanding the landscape is important, but so what is that testing going to look like, and how does that need to support that evolution? So using our SET or SET here as an example, it was important to us when we started to create this that we had a good, credible foundation. And that's where the VITA roots of 47.0 through 47.3 really came into play. We knew it was going to be important to have some credentials, some credibility behind us whenever we went to roll this out to different customers and potential clients. And so it was really important for us to tie this to the roots of what VITA is. And it also provides a level of understanding amongst the industry, which is it's going to be using some similar testing sequences, some similar test plans, so that it's not so foreign whenever a design engineer gets this test plan in front of them. This third blurb here isn't so much of a Samtec plug, but it's important to note that when we were sitting down to evaluate how we were going to do this, we knew we needed to offer this as a complimentary service, but also to bring the equipment in-house, because we knew that this testing was going to evolve. We just didn't know how and where and maybe even what industry it was going to do. So we needed that flexibility, and that was something that we did, which was purchase equipment, brought it in-house so that we could be nimble and flexible as this evolved. And we're going to talk about that here in a minute of the importance of that and how we've hopefully set ourselves up. So going a layer deeper into what severe environment testing is, you're going to see some familiar test sequences. And we'll kind of break this up into two halves again to talk about the industry standard testing and then also the mil spec. So you're going to see some familiar sequences in this. And what we did with that was to appeal to those design engineers that said, industry standard testing is great, but I'm needing a little bit more. We added a layer of aggressiveness into those same testings, those same test sequences. whether that be increased cycle count or increase 100% humidity. And that was the intent was to appeal for those individuals that said, industry standard testing is almost enough for me, but I need a little bit more boost there. And that's where you're going to see things like the altitude testing. So dielectric withstanding voltage testing is common in industry standard testing, but we added a layer of an altitude testing of 70,000 feet. To hopefully show some of that extremeness, and as we're talking about these rugged environments and harsh environments, to help provide some confidence as well. We changed the aggressiveness with the mechanical shock and vibe. So that kind of appealed to that industry standard marketing or industry standard market segment itself, but we knew we needed a test sequence to really hang our hat on from a military spec angle there. And that's where our temp cycling comes into play. We knew we really had to have a sequence that was going to set the bar high for performance and reliability. So we introduced a 500 cycle count test that takes 42 days. It exposes that interconnect to an extremes temperatures of negative 65 degrees to plus 125 degrees Celsius. And the intent there was to say, we have a test sequence in this test plan to really hang our hat on and to appeal to those design engineers that were really looking for something for their harsh and rugged environment. So hopefully that kind of gives you an idea of the landscape within the interconnect industry and what's available there, but then also how, as an industry, we have to continue to evolve and meet that middle ground testing. Because we're finding that there's a lot of flexibility there. So you're probably asking yourself, who's using this? And as a standard today, the military aerospace audience, a lot of you guys in here were certainly the driving factor behind this. We were trying to come up with something that was going to help fill that gap in that middle ground here, and that was pretty easy to listen to. The design speeds are continuing to increase. The need for high functioning commercial off the shelf interconnects the demand for that is continuing to increase. So that was really what drove this, was that audience. And we had a great standards team that's worked well with showing this sequence and this test plan out to individuals and providing feedback, and we're excited about kind of where this is evolving. And a fun fact here as well, as we got into this, we quickly realized that this wasn't just military aerospace. Those terms of rugged and harsh and severe are used across a multitude of industries themselves. So things like the medical, industrial, we've had several design customers and manufacturers come to us and say that, just the idea that we're testing altitude was enough for them to choose that interconnect through as they're breezing through that catalog. So it's really opened up a lot of avenues, and it's really shown us that there's a lot to be had there in that middle ground market when it comes to industry standard to that mil spec and everything in between. So this isn't so much about product, but I think it's important to talk about kind of the strategy behind the product that we chose to do, because as we've talked about here in several different presentations, it was important for us to have some flexibility in this. And so that's why we started with the mezzanine stack itself, and we wanted it to be solution oriented. So we've spent a lot of time, energy, and effort into this. When we got to the end of this, we wanted to make sure that it was solution friendly and it was flexible. So we started with the mezzanine stack, and where we've tested our C-Ray connector. We've tested high speed, low speed, power, and edge card, and multitude of iterations. And that was important to us because we wanted to make sure that if you're going to play in this middle ground, you have to have multitude of iterations, and you have to have flexibility for those design engineers when they're looking for these types of solutions, because that's the reason why they're in that specific market share itself. So to the right of this line, as some of you might have already been thinking about, is as we've got into this, as many questions have come in as answers. And what I mean by that is, that's great that you've done that on the mezzanine stack, but what about crimp and poke connectors? What about your twin acts? What about your optics? How are you all going to ruggedize and test your optics, your optical interconnects? And we don't have all those answers right now, but we're excited about where that's evolving to, and we're looking at what we can do to service those specific industries. When you add a layer of complexity when it comes to the components of optics and the active aspect, how are we going to change that testing plan to appeal to those ruggedized and harsh environments when it comes to optics and maybe sealed I/O or whatever it might be. So with that being said, that concludes my presentation, and hopefully if you have any questions, I'm open to any questions.